Hey guys, so today's video is called Linear Inequalities in Two Variables. And before we get into the inequalities, I'm just going to show you this, which is an equality. It's y is equal to 2. So we all know what that means. Is that any point along this line satisfies this, right? Because y is always going to be equal to 2 on this line. No matter what x value you plug in, it's going to be equal to 2. And it goes, you can't even plug in an x value because it's literally just y is equal to 2. But what if we had y is greater than 2? Well, in this case, y could be 3, 4, 2.1, a billion, a trillion, Google. It could be whatever, right? So if we were to represent that on a graph, it wouldn't be this line because that's y is equal to 2. And if we plugged in 2 right here for y, this wouldn't be a true inequality. This would be 2 is greater than 2, which is not. 2 is equal to 2. So instead what we're going to do is say, well, okay, this is kind of like the boundary, right? Like 2 is equal to 2, but it's not greater than 2. So we're still going to draw the line, but then we're going to dash it, and that's to say that 2 is not greater than 2. And then, instead, all the numbers that are greater than 2 are up here, right? This is 3, 4, Google's up there, here's 2.1. That's all the numbers that are greater than 2. So all we have to do now is, color in, or aka draw a squiggly line over here, to represent that this data set is all y is greater than 2, but not y is equal to 2, which is why we drew the dashed line, just to show that that's kind of the boundary. If this was y is greater than or equal to 2, then we could say, well, okay, 2 is greater than or equal to 2. It's equal to 2. So we can redraw in that line, and then this would be how we graph that inequality. And that's honestly the basics. If we had, like, y like this, so this is going to be just the straight equality y is equal to x. But if we had y is less than x, then it's going to be all the points below it, right? Basically, I mean, think of it as like, if it's hard to be like, oh no, it's diagonal, where does it go? Well, there's a couple ways to know. A, y is less than x. So if x is like 2 or something, then y is going to be have to be less than that, meaning it's going to be below it, because here's y is equal to 2, has to be below. And then it's going to be the same for all of these points, right? And because it's less than and not less than or equal to, you have to dash that line again. Pretend that's all dashed. And that's honestly the basics. You can graph any line like this, or any inequality, and then all you have to do to get this, like let's say you have to graph, y is less than x, draw the line y is equal to x, and then if it's, like this, not a y is less than or equal to, just a y is less than, then you dash it to show that that's the boundary, but it doesn't actually include that set of numbers. And then color it in below, or if it was y is greater than x, color it in above. Okay, so just another practice problem. This one actually requires converting the equation into y is equal to mx plus b format. So right now we have 2x minus 3y is less than 12. So, and we want to graph this. That's the goal of this. So I'm going to convert it to y is equal to mx plus b format, and then I'm going to graph it. So to do that, to get it to y is equal to mx plus b, we need to isolate y, right? So we're going to move whatever other term is next to the y term, which is 2x, to the other side. And by that, we'll do the inverse operation. So now we have negative 3y, and this cancels out, is less than negative 2x plus 12. And I could have written 12 minus 2x, but usually for y is equal to mx plus b format, you write the x before the constant. So now we have negative 3y is less than that, and we need to isolate just y. So to do that, we can divide by negative 3 on both sides, right? But again, whenever you divide or multiply an inequality by a negative, you have to flip the sign after you're done. So this is going to be y is greater than, not less than, but greater than, this is going to be 2/3 x minus 4. Cool, so now I have it into this format and we can graph it. This is going to be a very rudimentary graph. Not very precise. But this is going to be start at -4, right? Our b value is -4, meaning that's our y-intercept. So here we go. 2/3 x, so we're going to go up to 1, 2, over 3, 1, 2, 3. And this is going to be our line. So, but it's not y is equal to that, right? It's y is greater than that. So we know two things. A, the line has to be dashed because we're not including the line in this set of numbers, right? It's y is greater than that, not y is equal to that. So we have to dash the line to show that. Okay, the other thing that we know is that it's greater than, it's not equal to, meaning it's going to be above this line. So this is what our set of numbers is going to look like. Y is greater than 2/3 x minus 4 is going to look like bunch of colored in stuff above the line y is equal to 2/3 x minus 4.